Hello everyone, today I will present our work with the title Strict Path Flow Matching for In-Complement Multi-View Clustering. Next, in 5 minutes, I will talk about 5 paths. First, what is the IMVC? In real multi-view data, some views are missing because of sensors errors. Previous methods use games, VAEs, or diffusion to cover missing data, but they have problems. Games are unstable, VAEs make features blurry, and diffusion does not fit the clustering test well. Why is the diffusion bad for IMVC? There are 2 reasons. First, it starts from random noise. This wastes computation and ignores cluster information. Second, clusters are only separate when the noise is almost zero. In real steps, clusters overlap, which cause better results. This picture shows the problem. When the noise is large, clusters are missed. Only when noise is very small, the boundaries are clear. We want to keep clusters clearly separate at steps. To solve this, we use flow matching. It learns a direct path to transport the observed view to the missing view. It's a straight line. It's simple, stable, and has no random noise. This gives us 2 main benefits. First is a shortcut. We start from real data, keeping cluster information, no noise detour. Second, different cluster paths never close. This means clusters separate at steps. Our framework has 3 models: reconstruction, alignment, and our flow compilation. We use also auto-encoders to reconstruct each view. For alignment, we used constructive learning and entropy weld fusion to handle unreliable missing data. This code module is produced the target velocity for the strict path, so we add bidirectional loss to make sure the compilation is accurate. The whole model is trained end-to-end. We test our method on 5 datasets with different missing rate. Our method only needs 1 inference step. On the CUV data, on the CUV data, we bet baselines across missing rates. We are especially better when the missing rate is high. Application studies shows our loss functions help, and our flow strategy easily bets against simple prediction and diffusion. Our method is stable across hyperparameters and steps. 1 step is enough to get excellent results. The T-SNE picture shows the raw features are mixed, and our flow compilation features from clear and separated clusters. In summary, we proposed a flow matching framework for IMVC. It avoids diffusion noise problem and guarantees cluster separations. Our method achieves state-of-the-art results on 5 datasets. In the future, we will explore harder scenarios and large pre-trained models. Thank you for your listening.